Dave wants to practice vertical circles for a flying show exhibition. What must the minimum radius of the circle be to ensure that his acceleration at the bottom doesn't exceed 3 g's? The speed of the plane is 78 meters per second at the bottom of the circle. What is Dave's apparent weight at the bottom of the circular path? Express the answer in terms of its true weight. To find the radius, I use the formula radial acceleration equals velocity divided by the radius. I isolated the radius on one side and found out radius equals velocity squared divided by the radial acceleration. I plugged in the numbers. I used the 3 g's times the 9 times 9.8 meters per second acceleration due to gravity on the bottom. At the top I used 78 meters per second, and that was given to me, and I came up with a radius of 210 meters. And then to find his apparent weight at the bottom of the circular path, I use a formula. I use this formula. I used mass times gravity times the acceleration in the y direction, comes out to be 4 mg's.